Hey guys, what's going on? Paul here. Welcome back to another Cardano video. Today I'm sitting down with Pi again. Most people on the channel are going to be familiar with Pi. He's been on a few times to talk about Sundaeswap and a lot of more technical stuff on Cardano. Today we're going to focus on Aiken or Aiken. You're going to hear me call it both because I keep mixing up the name. But Pi, very welcome back on the channel. Thanks for the time.
Yeah, thanks for having me on. It's always a blast to be on your show.
Yeah, so look, like usual, we're going to jump straight into it. I'm going to presume most people know who you are. I'll let you give a 30-second intro, and then we're going to get into Aiken and why a lot of developers on Cardano seem to be turning towards that. And you've got a demo that really shows the, I'll say, massive improvement that it can make to smart contracts. So 30 seconds on you, and then into Aiken or Aiken. There we go.
Yeah, so for those who don't know, I'm Pi, like the number. I'm the CTO at Sunday Labs. We built and launched Sundaeswap, the first AMM DEX on Cardano. So, I reached out to you because I wanted to do a show on Aiken. And Aiken is a new programming language that people are building for Cardano. One of the biggest barriers to adoption, if you talk to kind of new people to the space, or you ask, hey, why are you still building on Ethereum and not Cardano? One of the common answers you'll get is that Plutus just isn't for everybody. So Plutus or Plutus TX is a Haskell-like programming language that was the only language available when Cardano first launched. It's what most of the dApps that you use are built in, and it's what was built by IOG. And what happens is you write some Haskell code, which, if you don't know, Haskell is a programming language really popular with academics, and it kind of led the charge on a programming paradigm called functional programming. I'm not going to get too technical because I don't think that's your audience, but feel free to go look up some of those terms if you're curious. But IOG built this language that looks a lot like Haskell, and it compiles down. So you take kind of the human readable code and it compiles down to a bunch of ones and zeros that run on what's called the Plutus virtual machine. And so when you submit a transaction and it has a smart contract in it, what that actually has is this bytecode for this Plutus virtual machine. And that virtual machine is also called untyped Plutus core, and it has a lot of really great properties in terms of like the formal verification that you can do on top of the like raw bytecode. So, for example, just as a small example, the execution model is really simple, and so it just completely eliminates a whole class of bugs that can crop up in Ethereum contracts called reentrancy bugs, where you have to keep track of whether the code kind of has race conditions and concurrency issues and things like that, that can cause like really, really bad hacks. And the UPLC virtual machine is just so much simpler that we can formally prove that it doesn't have anything similar or of the sort. Doesn't mean it can't be hacked. You can obviously always implement incorrect logic, but it does make it just like a simpler operational model to work with. And so we've got this Plutus TX, which is a Haskell-like language that compiles down to this like raw bytecode that is actually what runs when you submit a transaction. And so fairly shortly after, maybe like a year after smart contracts launch on Cardano, a bunch of big players started thinking, well, why can't we build something else, a different language that looks completely different, that compiles down to the same bytecode? And so there's a couple players in this space, Aiken, Helios language, PluTS. So all of these are attempts to generate the same underlying scripts, but without Plutus TX. Now, why might you not want that? Plutus TX is, and feel free to stop me if you have questions along the way, because I tend to be a bit rambly, but Plutus TX is very Haskell-like I mentioned, and a lot of developers aren't big fans of Haskell. It's just, it's just a very different way of thinking from kind of what most mainstream programming languages.
It's a very hard language to learn too. For anyone coming in new to it, it's it's not that similar to a lot of other languages that will be common languages nowadays.
Yeah, especially if you have background in another programming language, Haskell is very, very different. And so learning it can be very difficult. I've heard that like for somebody brand new to programming, it's actually not that much harder to learn than like, you know, something like Rust or something like that. But, you know, you kind of just have to like rewrite and relearn a whole bunch of programming kind of core concepts. Additionally, you know, one thing that the Plutus developers at IOG that were writing the language kind of misestimated is how much performance people would want to squeeze out of their smart contracts. And so there's a lot that, as it compiles Plutus TX down into this UPLC, it includes a lot of like extra type checking and basically a lot of extra scaffolding that makes your developer, when you're writing like a bit of logic, very easy, but makes like that takes up a lot of space or a lot of like CPU power inside the smart contract. And that means, like, for example, we, before our launch of the Sundaeswap platform, we squeezed and we squeezed and we squeezed, trying to get every little bit of performance out of those contracts. And even so, those contracts can do, you know, a maximum of 8 orders, or in practice, like 2 to 4 orders per batch. And that execution units and the optimization of that is really the limiting factor, but behind kind of how many orders we can process in a given period of time. And we'll have a demo later that shows kind of very viscerally and tangibly what that looks like. When people started building languages like Aiken and Helios, they had an opportunity to kind of reevaluate with the hindsight of having seen Sundaeswap's launch, for example. And when they compile down into code, they remove a lot of that. So, or they just don't include all of that extra kind of scaffolding. And so sometimes, like, you don't get fancy, it's kind of hard to explain without going super technical, but there's just like some fancier features that Plutus TX can offer that Aiken can't. But in practice, you hardly ever use those features for writing smart contracts anyway. And the performance wins can just be absolutely staggering. That's not to say, you know, I expect Plutus will eventually catch up in that optimization. So this is kind of a temporary lead that these other languages have. It's just, you know, the Plutus language designers didn't necessarily realize how hungry we would be for execution units. And so they just haven't gotten around to kind of gracefully removing that, which will probably come in a future Plutus version, like Plutus v3 or v4. If you want to go ahead and share my screen,
yep,
I can show off.
Yeah, and just on distractions here, probably the loudest thunder I've ever heard, and lightning is all going straight out in front of me. Strange here for Ireland. Now it's starting to lash rain, which isn't strange for Ireland, but just catching my eye a bit there if you see me. So here's the Aiken website. And is it similar to any other programming languages? Is that why developers are moving more to this as well?
Yeah, so they have a bit of sample code down here, and it's very similar to something like, I think the closest analog from like mainstream languages would probably be Rust. But, you know, that's going to, for programmers in the audience, that's going to give the wrong impression because it doesn't have a borrow checker. It doesn't, you know, just from a syntax perspective, I find that it looks very similar to Rust. And that's because the compiler is written in Rust. And so like a lot of that syntax just carried over. But, you know, so this is the website, aikenlang.org. It's being built by a company that a lot of you might be familiar with, TXPipe. They're also behind Demeter and a bunch of the like dev tools for indexing Cardano. And it's being supported by the Cardano Foundation. So the Cardano Foundation is doing a lot to fund its development. And K4Z, who is behind really great ecosystem tools like Ogmios and Kupo, and he worked on Hydra for a little while. He's behind Aiken as well, and so they are doing. It's kind of primarily three people. It's K-Tor-Z, Lucas, also known as RV Cass on Twitter, and Casey, also known as Microproofs. The three of them have just been absolutely knocking it out of the park. And the three main things that, when these languages started to pop up, I was really skeptical because, it takes a lot to write to write a programming language and to have like really high confidence that it produces correct code. Because one small compiler bug, and we saw this on Ethereum, there was a compiler bug that introduced reentrancy and like led to a bunch of hacks of I think it was a bunch of dexes. And so I was really skeptical of these new programming languages because I was like, I think it's really essential work, but it's going to take a very long time before they have kind of the confidence to be able to launch really big protocols like Sundaeswap on them. I think they've been developing now for like a year and a half, I think. And so I'm starting to get that confidence. And so on a whim one weekend, I was like, what would Sundaeswap's contracts look like implemented in Aiken? And let me tell you, the speed at which I got a working prototype up was phenomenal. And the main reasons for that are, one, the language, for me at least, is a lot easier to read. So I was able to iterate a lot faster. Two, it has incredible tooling. So this is one of the things that Haskell is really known for, is it has really bad tooling. So even just to start a project, it's like 3 or 4 days to install all the right dependencies and get your environment set up to just compile a set of basic smart contracts. And then there's a lot of boilerplate that you don't really understand what it's doing if you're new to smart contracts. And so that adds like several other days before you even get your hello world example, right? With Aiken, it's like 20 minutes. And that's just because they've focused really heavily on the tooling for installing Aiken the first time, for running and compiling smart contracts. It's a breeze and it's super fast. You get really great error messages. So this is a great example of that. If you're a developer, this will mean something to you. If you're not, don't worry about it. And their tooling is very kind of smart contract first. So what it's showing here is, and this is just like kind of a small detail, when you run your unit tests, it shows you what your execution units will be. So it shows you like, hey, you're exceeding the Cardano transaction limit in this test. And it's like the language is peppered with small details like that make it really like, oh, it knows that it's for Cardano. And that just accelerates your development. Whereas, printing out the execution units from a test is something that like wasn't possible with Plutus when we were first getting started. I haven't kept up with it, so I don't know if it's possible today, but just having those kinds of touches and those kinds of like care about that tooling makes it so you can get up and running really, really quickly. And so we decided, we got this rough prototype built really quickly. And so we decided to keep going with it. And we've now got most of the smart contracts written in Aiken and have been able to start doing some benchmarking.
Nice. Actually, we've talked a lot there about it, but just for people who aren't familiar with how a dApp is built up. So I know from talking at times, some people pick it up that a dApp is just a smart contract, but in reality, the smart contract is, or can be, a very small part of it. But can you just give the 60-second overview of what a dApp is made up of, with off-chain code and the contracts, and I suppose specifically for Cardano?
Yeah, sure. And I'll preface this by saying there are a bunch of different architectures. So like there's not one right way to build a dApp. But in general, a dApp is divided into 2 broad categories of code: the on-chain code and the off-chain code. The on-chain code is, at least for Cardano, is the thing that implements all of the authorization. So are you allowed to spend funds? Are you allowed to update that variable, right? So like, I'm going to update your vesting time to add 6 months to it or something, right? Like if you have a smart contract that has that logic, the smart contract is implementing who is allowed to either access funds or who is allowed to update different kind of parameters of the contract that you have between you and somebody else. For example, for Sundaeswap, the smart contract is enforcing that the pool has a certain amount of funds, and when you swap, you deposit, some amount of funds, and it's enforcing how much you're allowed to withdraw from the other side of the pair, right? So it's enforcing just that logic of like, this is or is not a valid operation for the dApp. But then there's a whole suite of things that are what are called off-chain. And this is code that is not being run by every stake pool operator. That's kind of really the distinction. A smart contract, when you submit a transaction, gets run by every stake pool operator. The off-chain code is run, by something off-chain, by not the stake pool operators. So one option is to have a back-end server that's implementing that logic. It's kind of calculating how much you should be able to withdraw and then build that transaction that withdraws just that amount and no more, right? That's a bit of off-chain code. And then the enforcement that you did that calculation correctly happens by the smart contract, by the on-chain code. Also something like showing the total trading volume over 24 hours, right? That's not something that happens on-chain in the smart contract. It happens off-chain by looking at whatever happens on the blockchain, and then you can report that in the UI. And so that's kind of the distinction between on-chain and off-chain code. And Aiken is really focused on the on-chain portion of that. It's really, let's implement some code that decides whether somebody is allowed to do something or not.
Great. So you have a demo then, which you told me some of the figures before. So looking forward to seeing what it all looks like, because it sounds like it can make a massive difference to what's happening on chain.
Yeah. So just to frame some context, right? So this is a stream of the transactions that are happening on Sundaeswap right now. And each one of these, right now, our volumes.
Can you zoom in on that slightly, just for anyone who might want to see it?
Yep. Each of these is what's called a scoop transaction, which is taking one or more orders. So that's these. So this is somebody swapping Copy for ADA, and here's the output of that. And it's basically processing that order against the pool. And this pool has 6.8 ADA and 58,000, or 6.8 thousand ADA and 58,000 Copy, right? And then people doing a lot of trading against Copy, but here's one for WMT, here's one for Sunday, right? And right now, traffic is fairly low, so you'll see a lot of these have one order in them, and they process. So if I pick one of these at random, this was at around 12:49, and if I go and look at when the person placed the order, 12:48, so they process like within a minute or two, right? But if you were around for our launch, you'll remember that the amount of orders we can process in one of these scoop transactions is limited. Theoretically, each one of these can process, I think today it's a maximum of 8 orders. And that's because of the execution, like the protocol parameters have been raised a number of times after our launch. At launch, I think it was a maximum of 4 or 5 orders per batch. But I should caveat that by saying, because of a quirk in how the Cardano node operates, or how smart contracts operate, they will reorder the inputs to your transaction. And this isn't something that we realized when we launched. And so if you just process a batch of 8 orders, more often than not, they will execute out of order, which isn't necessarily fair to people, right? People expect that if they got their order on chain before somebody else's, that it will process in that order. And so we have to break these up into smaller batches. And so in practice, today we can process 2 to 4 orders per batch on average. This is, MinSwap suffers from the same problem, and they have roughly the same throughput. So, that 2 to 4 orders per batch is kind of an inconvenient number if you want to do high volume. And so, I put together this visualization. I think this is the right one, that shows, we tell people the numbers of how many orders were filled or were processed when we launched, and it's, this visualization kind of really puts a real note on that. So this is kind of a visualization of what our launch looked like. And you can see kind of all of these orders coming in are orders that people are placing. And each of these kind of filled colored circles are those batches, between 2 and 4 orders per batch that were being processed at our launch. And you can see how quickly that backlog filled up. So if you were around at our launch and it took a while for you to get some Sunday, I think the longest somebody had to wait was 9 days. So it was a really bad experience, and it was largely limited by, how many of these orders we could fit in a batch. And like I said, at the time, it was a maximum of 4. And so it was really hard for this to keep up with that surge of demand. Now that kind of that demand, within a month or 2, that demand had bled off. And so it was, you could place an order and it would process almost immediately. But you still see some of that with the launch of popular tokens like Snake or Ron, right? And so you'll see these big backlogs form. And so what I want to show off, right, if this is the mainnet transaction, we've been building and optimizing our Aiken smart contracts. And previously, we'd announced that we got that up to 19. And so today, I'm excited to announce that we've gotten that up to 25 orders per batch, right? And so if you look at a transaction like this is 1 order per batch, right? And I should have had an example with 4 orders per batch just to give an emphasis to that. But this is an order on preview that executes 25 user orders per batch. And I was just floored the first time I saw this, because
massive difference. And is that 25, like you were saying, right, theoretical before was it 6 or something, ended up being 4 at launch? And is this theoretical 25, or this is, you could do this every time if the orders were sitting there?
Yeah, so this is, one of the things that these new contracts give us the opportunity to do is address, things that we've learned since our launch, like the way that orders get reordered. And this is processing orders basically we fixed that bug where even if the smart contract reorders these orders, we include in the redeemer a number, and we process them in order of that number, which allows us to kind of express to the smart contract what order they should be processed in. Which means that we no longer have that caveat. Our maximum throughput is our maximum throughput, and it doesn't incur any unfairness on users by doing so. Now, in practice, we're not going to be able to get a block or a scoop in every block. We're going to be sharing space with other orders. There's not going to be 25 orders to process, or some of those will be deposits, which are a bit more expensive and will bring this down. But in practice, or in theory, this is roughly about what we'll be able to do every block. So if there's a big meme coin launch, or we just see a general increase in activity, we'll be able to do this kind of load very consistently, multiple times per block. And if I go here, the transaction fee to process this is 1.35 ADA. To process 4 orders, it gets closer to 2 ADA. And if I look at the transaction fee here, it's 1.33 ADA. So it's, even with processing 25 orders, it is a cheaper transaction fee for the scoopers. And so, right now we still have it at 2.5 ADA per scoop or per order, but that gives us the room to bring that down, right? Because one, the scoopers are paying less per scoop, and two, we're processing more per batch, so it's easier for it to be profitable for the scooper, if that makes sense.
Yeah, it's a massive difference to what's there, and makes it far better for the end user too. And like you say, cheaper batcher or scooper or whatever, different dexes call them different things, but cheaper fees for the end user as well as increased speed. It's kind of a win-win for them. And is the cheaper fee, even though it's doing more transactions, is that because it's a smaller size with the script and what's included?
Yeah, it's because it's a little nuanced, but it's basically the transaction size is much smaller. So this transaction is 13 kilobytes, and this transaction is 3.8 kilobytes. So that's where a lot of the savings come from. And the like memory units, we use less, basically less execution units to process those 25 transactions than we would with like 4.
So that means even more of them can fit into a block too.
Yeah.
So when you have other dApps using these types of contracts, it's smaller overall.
Yeah, absolutely. So I thought it would be fun. This isn't going to be real data, so to speak, but I thought it would be fun to show off. I pointed it at all of the same kind of events from like placing orders as our launch, but I updated it to show, what would it be like if every one of the scoops that we did do that only processed, 2 to 4 orders processed 25 instead. So if you remember the visualization I had here, it's still going. It's kind of filling some of these in. I think this is like a few days after we launched, and people are able to get more scoops in. So the scoopers were able to figure out some optimizations to their setup, so you can see these going in more consistently. But we still have a huge backlog, right? This is 12,000 unfilled orders, and in total we've processed 1,500 orders. So just absolutely staggering amount of interest. This is what that same set of orders, that same load would have looked like if every single one of them was filling 25 orders at a time. So, hopefully that makes it really clear, like how big of a difference this makes, and how, there's still a backlog that forms, unfortunately, just because our launch was so staggering, but we're able to keep up with that backlog a lot better. Right. And so if I left this running like I did the other one, you'll see we fixed that same bug that or the scoopers are able to optimize their setups, and you'll just see it kind of bleed through this. So I'll leave that running for a few seconds while you if you have any questions.
Yeah, you can see there it's already nearly caught up with what the current contracts are doing in terms of orders filled, and it's only running a few maybe 30 seconds now at this point. So it's massive in terms of, and not just for Sundaeswap, but across Cardano, to get these types of speed improvements is absolutely massive. And at the end, we need more dApps on Cardano. If development is easier for Cardano developer, for people coming in to build on it, then that's a win-win for everyone. So what's next? Or now you're still using the original smart contracts. When might we see something like this implemented on mainnet?
So I'm allergic to timelines at this point, but we're working hard on this, and it's going to take a while, right? Because we have to, like I said, get confidence in the in Aiken as a language and in our rewrite. And so we want to write a whole bunch of tests for these contracts, not just, the obvious ones, but the unobvious ones, the things that like would reveal if there was a bug in the Aiken compiler. Things like, what if somebody tries to run this with just a completely malformed transaction? And we want to do some fuzzing work and things like that. We want to we need to upgrade all of our off-chain infrastructure. Oh wow! So you can see like we're basically already caught up. And this is like a day after our launch instead of like 3 weeks after our launch before we even started to get caught up. So I think that, you know, it almost makes me cry and wish that I had this because of the stress that our launch induced when we had this huge backlog. But you know, so we want to work. We want to kind of fill out all these tests. We want to document it. One of the things that we're committed to doing with this rewrite is open sourcing our contracts. So we want to make sure that they're documented and make sure that people can, you know, clone and run them and learn from them themselves, right? When we launched, there was this landscape where, you know, we were really worried about somebody just like taking our smart contracts, flipping them, and launching a competitor with all of this work that we had poured in. I think nowadays there's enough DEXs out there, there's enough that have been open sourced that, you know, it should be fairly like that. The risk of that is much lower. And so with these new contracts, we want to open source them kind of from, not necessarily from the get-go, because I think it's important to be able to develop in private and be able to try random things and not get like scrutinized for every little decision that you're making. But we do want to kind of clean those up and make them presentable for the public. We want to, like I was starting to say, we need to upgrade all of our off-chain infrastructure. So, you know, we have all of this stuff, like I said, that computes the 24-hour daily volume that was written assuming there was just one version of the protocol that now needs to be updated so that it can say, hey, I'm watching these old contracts because they're still going to exist forever, basically. And I'm watching these new contracts, right? We need to upgrade the scooper software so that it can be submitting scoops to both different protocols. So there's still quite a bit of work to do. And I won't give a timeline, but, you know, that kind of segues into one of the things that I wanted to talk about. Last time I was on your show, we talked a lot about Hydra, and then I kind of bookended it with a call to action to vote on our Hydra proposals because we thought we could contribute something really well or really good to the space. And there's 2 proposals out of the 7 that we have that are focused on this Aiken or on a new version of our smart contracts. So at this point, we're pretty confident that we want to go forward with this Aiken stuff. And we want to hire another developer to help accelerate that process so that it's, you know, again, allergic to timelines, but instead of taking this long, it will take this long, for example. And so we're asking for Catalyst funding to help us do that for the Aiken contracts. And we want to get them audited, right? So we're asking for Catalyst funding to get this set of contracts audited. When we originally created the proposals, we were still kind of undecided on whether we'd go forward with Aiken. So, you know, we have this version of the contracts rewritten for Plutus v2. And those get us up to like 10 or 11 orders. So there are some improvements, right? But it's not the same improvements that we get from Aiken. And so we will probably go forward with the Aiken contracts regardless of whether we get funded or not. But it's just going to make a really, really big difference on our timeline for that. So, you know, if you're a supporter of our project, if you want to, and, you know, we may also make the decision not to open source to give us a little bit of a competitive edge, you know, if we have to remake or regain some of that ground without Catalyst funding, right? So, you know, the Catalyst funding ensures that we open source it and helps us accelerate that process dramatically. So, you know, I think you'll probably include those into the description, but please go consider voting for these 2 proposals, as well as our other 5.
Yeah, I can put links to them down below, and the Hydra video we done a few weeks back. At this point, anyone that didn't see that and is interested in what Hydra is capable of, I can link that one down below as well. It's definitely one worth a watch if you haven't seen it. And just when you're talking there about the improvements, so Plutus could do up to 1011 now, but when you compare that to what's possible with Aiken, it just doesn't seem like it's the way forward. If obviously once you're happy with Aiken and how it works, and is there many companies auditing contracts on this yet, with it being so new?
Yeah, we've talked to M Labs, Anastasia Labs. I mean, we've started auditing Aiken contracts. So we just did the audit for the new JPEG store contracts, but obviously we're not going to audit our own contracts. But yeah, there are companies out there that are auditing Aiken because there are companies out there building on Aiken. So I know Levy Finance has been built in Aiken. So we're going to see more and more companies auditing. And really a lot of the value from audit comes from the conceptual double checking, right? And the language is a little bit less important. And so the skills of a good auditor transfer fairly well between languages.
Okay, and just completely aside on that, when you're auditing, do you look at the compiled code or do you look at it the uncompiled code, or which you look? Because you were saying before about that potentially when it's broken down that that there might be issues there. Which version do you look at?
Yeah, so I think the bulk of the work is usually done on the unaudited code. And then, depending on how much you're paying for your audit, basically, it can involve not necessarily looking at the compiled code, because that's just a bunch of bytes. It's really hard to have confidence in anything that you're auditing there. But in terms of like running simulations against that compiled code, a really good audit will like have a bench, like a framework for running untyped Plutus core through its paces.
Okay. Yeah, look, I think we covered a lot there today. Hopefully showed people what's possible with Aiken. And
just the last thing that I'll say that I forgot to mention is I focused a lot today on the performance, because I think that's the standout winner in the benefits of upgrading to Aiken. But I will also call out there's a number of really cool features that we've basically thought of since our launch that we were able to incorporate. And I'm not yet going to leak what those features are, but I think you'll be also really excited by those.
Okay, so I have to book another catch-up call to find out what they are later. So yeah, I think, and like on top of speed and everything like that, simplicity, I'm sure it's not simple to develop in them, but it sounds like it's a lot easier to develop in that than coming in from non-Cardano side to build in Plutus or Haskell or anything like that. So look, anyone watching, please do share it out. Let others know what's possible. Some of the links that you mentioned, I'll leave links down below. TX Pipe, Dmeter, some really good resources there for developers to spin up environments very quickly, not have to build everything from scratch themselves. So I'll leave links to all of that down below. And questions, leave them below. Maybe we'll do a follow-up at some point too to talk a bit more on this. Maybe even look at getting some of the Aiken guys onto the channel too. Thanks, Pi, as always. I appreciate it. I'll leave all the links for your catalyst below too. And everyone watching, talk to you soon.